says Brittany sold 5 more candy bars than Ashley. Tyler sold twice as many candy bars as Brittany. If there were 39 candy bars total sold by Ashley, Brittany, and Tyler, which equation below would represent this relationship? All right, so they're saying if we add up the total that each person sold, in total we're going to end up with 39, right? So if I took Ashley, Brittany, and Tyler, and I added them all up, my total is 39, right? I just need to figure out what to use as my variable or what to represent each one of those people, right? Okay, so Brittany sold 5 more than Ashley. Do we know how many Ashley sold? No, just Ashley. Right, that's all. So we have no idea how many Ashley sold, and they compared it to Ashley. So Ashley must be our unknown, or our variable, right? So Ashley is just A, because we don't know how many Ashley is. But for Brittany, they said Brittany sold 5 more than Ashley. How do I write 5 more than Ashley? 5 plus. So A plus 5 would be Brittany, right? Okay. Tyler sold twice as many candy bars as Brittany. What does twice mean? Times 2. So 2 times, what did we write down for Brittany? For Brittany, we wrote down A plus 5. Good. So 2 times A plus 5, right? Okay, I can't simplify what we have written for Ashley anymore, right? It's just an A. I can't add what we have for Brittany, because a variable and not a variable. But on Tyler, could I simplify what we have written here at all? What could we do? Right. Good. We're going to distribute that 2. 2 times A would give me, like you said, 2A. And 2 times 5 would give me, good. And now we have it simplified, right? Okay. So we said if we add all these up, it's supposed to equal 39. So over here, when I look at my equations, I need one that has all of these equal to 39. So we need to, after we've distributed, go back and combine like terms, right? So I have 1A here, 1A for Brittany, and 2 A's for Tyler. How many A's is that all together? 4, okay? So 4A. And then I'm going to combine my constants. So we've got a 5 here and a 10 here. How much is that all together? 15. Good. Equals that total of 39. So what would my answer be here? Very good. All right. So today we're going to be adding on our last step for solving equations, the last kind of thing we could see. And that is having variables on both sides of the equal sign. So far, our variables have all been on one side. Today, we're going to talk about what we need to do if the variables are on different sides. And it's pretty similar to what we do for those constants on different sides. So we should already have a pretty good idea. All right, so example 1, we're going to solve these equations. Okay, so what would you guys want to do first on number 1? Add like terms. Okay, so on this side, can I combine the 6k and -3? On this side, can we combine the k and the 13? Okay, so there's no like terms to combine right now. So that means we're going to have to start moving stuff, right? Okay, so if we're trying to solve for k, that means I need all of my k's on the same side, right? Right now I have 6 over here and 2 over here, and I want them all together. So what could we do to move the 2k over here with the 6k? Very good. So I'm going to subtract 2k from both sides of my equation. All right, so now I've got 6k minus 2k. What's that going to give us? And then we still have minus 3 equals 13. Okay, what would we want to do now? Good. Add 3 to both sides. And what is 13 plus 3? Very good. So what would our last step be here? Good. And 16 divided by 4 is A must be 4. All right. Okay, number 2. Again, we got those variables on different sides, right? We need them all on the same side. So how would we put the p's together? What do you guys want to move?
Plus 0.2.
Okay, good job. So plus 0.2p on both sides. So over there, those will cross out. So on the left, all we have is the 8 equals, what is 0.4 plus 0.2? Good. So we have 0.6p minus 10. All right, what do we want to move now? Good. And what is 8 plus 10? Nice. So I have 18 is equal to 0.6p. Good. And 18 divided by 0.6 is, very good. So p must be 30. Good job. All right. What about number 3? What do you guys think we should do first on number 3? What did you say? Very good. Over here on the right side, we've got some like terms. We got a 7c and a 2c that are already on the same side, right? So we have 7c plus negative 2c, or 7 minus 2. How many c's is that going to leave us with? 5c. Very good. So remember, if they're on the same side, you just put them together. You don't have to move them by adding or subtracting, okay? All right, so now what should we do? Very good. And what is 8c minus 5c? Very good. So we have 3c plus 1 equals negative 14. What do you guys want to do next? And what is negative 14 minus 1? Very good. And my last step would be to 5. Very good. So we end up with c is equal to, nice. All right, we got one more here on the front. So looking at number 4, what do you guys think we should do first here? What? Parentheses, right. So inside the parenthesis, there's nothing to do, but we have something in front to distribute in, right? What are we going to distribute? Is it 7 or is it negative 7? Negative 7. Okay, so I'm going to bring down my 5. I've got negative 7 times t. What's that? Good. And negative 7 times positive 1. Negative times a positive is a negative. Good. Is equal to that negative 10t plus 3. All right, what should I do now? Combine. Very good. Over here we've got a 5 and a negative 7. They're on the same side, so we just put them together. What is 5 minus 7? Very good. So negative 2 minus 7t equals negative 10t plus 3. Okay, what do you guys want to move now? The 10. Okay, so if it's negative, to move it, we would. Good. Right, so over here I've got negative 7t plus 10t. Good. So we got negative 2 plus 3t equals, all that's left over here is the 3. Very good. And 3 plus 2 gives us, very good. Nice. And will 3 go into 5 evenly? No. So we're just going to leave it as that fraction, 5 over 3. All right. it over on the back, and we just got a few more examples to look at. Okay, number 5. So we actually had one like this. I believe it was on 1.4. Do you guys remember what we said we do when we have two fractions set equal to each other like this? Cross multiply. Very good. Okay, so I'm going to multiply this direction. So I would have 6 times all of this, m plus 15. And then the other direction, I'll have 3 times m plus 9. Okay, so now we need to simplify. What do we think we should do first? Distribute. Very good. So I got 6 times m, which would be, very good, and then 6 times 15. Good. All right, and then we also have to distribute there on the other side. 3 times m, very good, and 3 times 9. Nice. Okay, what do you guys think we should do now? Minus the 3, okay, good. So minus 3m from both sides. What is 6m minus 3m? Nice. So I have 3m plus 90 equals 27. Okay, what should we do now? Alright, so we got 27 minus 90. Very good. And then our last step would be to 5. So what do we get for m? Nice. Alright, we got one more. Again, what are we going to have to do here? Cross multiply. Good. So this direction we got -1 times d minus 1 equals, from the other direction, we've got 3 times d plus 2. Alright, so what do we have to do first on both sides? Distribute. Good. So I got -1 times d. What's that? Negative d. Good. And -1 times -1. Nice. And then over here I got 3 times d. Good. And 3 times 2. Nice. Alright, so we distributed. What should we do now? The negative d, okay. So I've got 3d plus 1d. What's that going to give us? Good. Okay, what should we do now? Very good. And what is 1 minus 6? -5, very good. So -5 equals 4d. And last step would be to, very good. And will 4 go evenly, will 4 go evenly into that -5? No. So we're just going to leave it as a fraction, -5/4 as our answer. Alright. Okay, and then we got one word problem. Okay, so this problem here at the bottom says that Rachel and Amanda are planting tulip bulbs. Rachel has planted 45 bulbs and is planting at a rate of 30 bulbs per hour. Amanda is planting at a rate of 36 bulbs per hour and has planted 27 bulbs. How long will it take Rachel and Amanda to plant the same number of bulbs? How many bulbs will that be? Okay, so what did they ask? How long it's going to take for what? Have the same, right? So that's the key word there, same, right? So in an equation, what symbol in there is going to mean same? equals. Very good. So when they say same, we know that means equal. Okay, so we want Rachel and Amanda to be equals. So basically, it should end up being Rachel equals Amanda, right? And we just need to plug in the information they gave us to turn it into an actual equation, okay? So for Rachel, it says that Rachel already has planted how many bulbs? 45, good. Okay, so we got 45 for Rachel. And, what does the word and mean? Addition, subtraction, addition, very good. And she's planting at a rate of 30 bulbs per hour. So how do I write 30H? Very good. All right, and that covers Rachel, so then I have my equals. Now we're going to fill in for Amanda. So Amanda is planting at a rate of what? 36 per hour. How do I write 36 per hour? Good. And she is already planted 27. So what am I going to tag on? Plus 27. Very good. And they just want to figure out how many hours it's going to take for this to be a true statement. So now we solve. Okay, so what do I want to do now? What do we want to move? Good. We are going to minus 30H from both sides. All right, so then we got 45 is equal to 36 minus 30 leaves us with, good, 6H plus 27. Okay, what should we do now? Subtract what? Good. All right, and what is 45 minus 27? Good. So I have 18 equals 6H. And my last step would be to divide. So what do we end up with for H? Nice. So they asked how many hours will it take? Well, it's going to take 3 hours for this to happen, right? And they also asked a second question. What does that second question say? How many bulbs will that be? Okay, so we need to figure out if they plant for 3 hours, how many will they have planted? Well, all I would need to do is take that 3 and go plug it in, right? So plug in 3 for H. Okay, so let's do it first for Rachel. So Rachel's side was 45 plus 3 times H. And what are we plugging in for H? Good. All right, so order of operations, we've got multiplication and addition in this problem. Which one comes first? Multiplication, right. So 3 times 3 would give us 9. So I have 45 plus 9, which is, oh, sorry, it's not 3, that's 30. I'm sorry, y'all. I didn't read the question very good, did I? Okay, 30 times 3, which would be 90. And 90 plus 45 would be 135. Very good. And we also could plug it in for Amanda, but what did we know was supposed to be true about Amanda and Rachel? They're equal, right? So for both of them, it should be 135 volts. Okay? All right. Yes. So if you actually plugged it in for Amanda as well, that would have been 36 times 3 plus 27. So 36 times 3 plus 27 is also 135. So it did work out. They both planted 135, and it took 3 hours for them to be equal. Huh? What's not equal? 135 isn't equal to 135?
It's not even.
Why is it not equal?
That's funny.
Huh?